Hi, in this session we are going to cover minimum spanning tree. First we will see what is spanning tree, then we can go for a minimum spanning tree. So a spanning tree is a subset of the graph given graph G which has all vertex covered with minimum possible number of edges. Suppose if we have a graph with 10 vertex means the minimum number of edges should be 9, then only it is a minimum spanning tree we will be considered. Now here the graph is a collections of vertex with edges, so V for vertex and E for edges we are describing here. Now going here you can see this simple graph ABC graph G. So for this graph what are the spanning tree means, ABC, this model is one of the spanning tree, and this model this is one of the spanning tree, and this is one of the spanning tree. So three different type of spanning tree, as it is a undirected graph and also not weighted, so we are getting many number of spanning tree. Suppose weight is given, so here among these three which one has minimum weight, that is minimum spanning tree. Now you can take this graph, from this node to this node the weight is 1, from this node to this node the weight is 2, from here to here the weight is 4, like this for all the link they given weight. Now for this weight what are the spanning tree we will see. So these are the different types of spanning tree available. Now we are going to calculate the weight. Now for this one 3 plus 1 plus 2 it is 6. Now this is also one spanning tree, 3 plus 2 plus 1, this cost also 6, this cost also 6, this cost also 6. So these are the various spanning tree. Among this you can choose any one which has minimum weight. Now we can go for an actual problem. So this is a given problem. So how many vertex is given means totally 6 vertex given, starting from A, B, C, D, E and F, and edges with weight they have been assigned here. Now for this we can apply minimum spanning tree algorithm to predict the which graph layer will have minimum spanning tree. Okay, now the step 1 we have to choose among these all the edges which one has minimum edges. So minimum edges ED or DE, any, because it is an undirected graph you can choose ED or DE. So it is 2, that is the first one. The next one is 3, that is AB or BA, anything you can take. So like this you need to take one by one. So I have taken everything. First one is ED, then AB, then AE you can take, or CD you can take. AE is 4, or you can take CD, it also 4. Then BC, then EF, that is 5, then CF it is 6, then AF 7, then BF, and finally CF. Okay, so this is step 1. Now going for step 2, now take one by one edges and draw the line. If it forms a circle, that is if it forms a loop, you need to remove that edges, else you just keep on adding all the edges, and once you touch all the vertex you need to stop the problem. This is only two factors you need to consider. If it forms a loop you need to remove the edges, and if you touch all the vertex you need to stop the problem. Now first one I am going to take ED. So ED I am going to take, I have marked ED. Now still many vertex are there I need to touch. So next smallest thing is AB I have taken. So AB, still I didn't cover all the vertex. The next one is AE or CD, I can choose anything. First I am choosing CD, then I am choosing AE. Still F vertex I didn't touch. Then I am choosing BC. If I choose BC, it will form a cycle, right? So it should not form a loop. So I am removing BC. The next smallest thing is EF. Now I am stop my problem because I touch all my vertex. Now you can see here total weight of this 2 plus 3 plus 4 plus 4 plus 5 is 18. Now my minimum spanning graph is this one. So this is my minimum spanning graph. So I will show the general simple algorithm for this. You can see here. So first remove all the loops and parallel edges for the given graph. So that is point number 1. The point number 2 is sort all the edges in non-decreasing, or that is increasing order of their weight. Now pick the smallest edge check it forms a cycle with the spanning tree. If it forms a cycle, just remove that or omit that. Okay, and parallelly you need to check whether you touch all the edges or not. Okay, so this step 2 will be repeated until you are finding v minus 1 edges. That is, for example, 10 vertex is there, means you need to find 9 edges. Now previously in our problem we have totally how many vertex? A, B, C, D, E, F. So totally 6 vertex is there. So you need to find 5 edges. So 1, 2, 3, 4, 5. So we have 5, determine the 5 edges, that is v minus 1 edges, and the total weight is 18. So this is Kruskal algorithm, and this is the problem for solving the Kruskal algorithm. Thank you.